Hi everybody, Andrew Sampson with Ross Video, and in this tutorial we're going to introduce you to our new Visual Logic feature, which we're releasing in version 5.5. This is one of the major feature releases at NAB 2014 this year for us. So what Visual Logic is in essence is the ability for you to build smart templates, or templates that can control things like conditional animations or conditional position of objects, based on data values, for instance, or text input, or a variety of different parameters, without having to use script. So in the past, with all previous versions of Expression, this type of scene-based logic would have had to be implemented with scripting. Now this can all be done in a visual node-based environment, which looks like this. So we'll open up the Visual Logic editor. There's two places you can access this feature. You can right-click on your scene thumbnail and select Edit Visual Logic. Or you can go to the top of your viewport and you'll see an icon, and it says Edit Visual Logic next to your Show and Hide camera and light controls. Click on that, it'll bring you to the same place. So this is what the Visual Logic interface looks like. Essentially, you have different blocks that you can build, and you can connect outputs of those blocks to inputs of other blocks to either modify the values that we're retrieving, or to send those values to the input of another object. So in this example, what we're doing with Visual Logic is we're controlling the position of text objects based on the height of the bounding box of the previous text object. So this is a really practical example of something that a lot of customers are going to want to use for traditional multi-line templates. So you'll notice that when I insert a line break, line 2 drops, so does line 3 and 4. And our background object, which is a cube in this case, so we'll just rotate this around. You'll see that we've got this reflective cube with our text on it. It's also changing its Y scale in relation to the bounding box height of that text object. And you can do this for each line. So as I add line breaks to the second line of text, we drop line 3 and 4, and we increase the scale of the background object. So very practical example. So we're going to deconstruct this. Obviously, there's a lot more you can do with Visual Logic, but this is a good introductory example and give you an idea of some of the mechanics at play here. So we're going to create a new scene. And in this scene, we'll have a background. So we'll use our background material. There it is. And we're going to have some text objects. So we'll create a text object. This is line 1. And just like the example scene, we're going to use 4 lines. So we will copy this text object, 1, 2, 3, 4, and we'll use our auto distribution functions to spread these out vertically. So we'll move line 4 down, we'll select text 1 through 4, and we will distribute objects vertically, so there are 4 lines. Okay. Next step. We're going to want to make a few connections here before we actually start building our Visual Logic. One trick that makes this particular design a lot easier is taking your text objects and making them children of one another. Now, when you make an object a child of another object, its transform options become relative to its parent, or transform values, I should say, become relative to its parent. So if I make text 2 a child of text 1, its Y position is now in relation to text 1's Y position. So we're either positive or negative X number of units from the parent object. So this makes it a lot easier when we're trying to add positional values to this, because we are simply adding to its relative value in this case. We don't have to worry about its absolute position inside the scene or inside of our viewport. So I'm going to do this for text 3 as well. It'll become a child of text 2, and text 4 will become a child of text 3, just like that. Now, in my example scene, I also had all of my objects inside of a group object, which just made it a little easier to manipulate the whole group. This is really optional. It comes down to what you want to ultimately do with this scene. For instance, if you want to have all of these objects, fly in or rotate in, it's obviously a lot easier if they're grouped together. So that's optional. Next step, we're going to start building our Visual Logic. So we'll open up the Visual Logic editor, The Visual Logic Editor is separated into two halves. You've got objects on the left and you've got function blocks on the right. So objects are where you can retrieve objects from your scene or from expression in general. And then function blocks are effectively modifiers that you can use. So for instance, data sources. You can incorporate data sources from the data link server into your Visual Logic. You've got logic function blocks like and, equal to, greater than. So if you want to do comparisons. Math, simple addition, subtraction, multiplication. These are all available here as well. Offsets, these are things that we're going to use in this example. Basically allow you to augment the values that you're receiving from a specific block. Selectors, strings, timers and counters, and vector math. So there are a lot of different function blocks, and we'll be adding to this over time based on your feedback. So please feel free to let us know what features you'd like to see. We're going to mainly focus on the math function blocks for this particular example, but obviously in your own experimentation, feel free to try some different function blocks. So what do we need to do in this scene? Well, we need to position each text object based on the previous text object's bounding box. So we already know that we're going to be dealing with two values here. We're going to be dealing with the bounding box height, and we're going to be dealing with the y position of each object. So let's see what we can gather from the objects in our scene. So we'll go into the scene objects list. Inside scene objects, you'll find all of the objects that exist in the scene that you're currently working on. So text 1, there it is. What can we retrieve from text 1? Well, we've got bounding box, events, faces, texture coordinates, pivot, position, rotation, scale, name, text, which is its string value, its opacity, and its visibility. So we obviously need to use its bounding box in this case. So we're going to grab the bounding box, and we're going to pick a specific property from that list. So we need the bounding box height. So we'll drag bounding box height onto our Visual Logic Editor. So there it is. Now, bounding box height only has an output. So this is an example of a block where we can only retrieve a value and send it somewhere else. Some other properties, for instance, scale, will actually have an input and an output. So we can send a value into it and we can send a value out of it. Right? So that's always indicated by the green dot on the left-hand side and the yellow dot on the right-hand side. So we'll delete that. We don't need that right now. So here's text 1, bounding box height. Now I need to take the bounding box height of text 1 and use it to influence the y position of text 2. So we'll select text 2. We'll find its position, specifically its y position, and we'll drag that onto our Visual Logic Editor. And right off the bat, we can take the output of our bounding box height and send it to the input of our position, y, just like this. And I just dragged that arrow from the output to the input. So something has happened in our scene, and let's take a look at what the effect of what we just did is. So we'll take our scene, we'll put it on line, and we'll go to line 1, and we'll start inserting some line breaks. And what you'll see is the text objects are moving, but they're moving in the wrong direction. So my 3 additional text objects are actually moving up. So as the bounding box height grows, we're always going to get a positive value. So what's happening here is the bounding box height is being added to the current y position of this text object. And obviously when we're affecting an object with a positive value in terms of position, it's going to move up instead of down. So what we need to do is we need to modify the output value of our bounding box height to negate it. So we need to have a negative value coming out of that. So how do we do that? Well, we're going to use a function block for that. We'll go into our math function blocks. I'm going to grab a multiply function block and drag it onto my Visual Logic Editor. We're going to take the output of our bounding box height, send it to the input of our multiply function block, and then send the output into our text position y. Now, to negate this value, I need to multiply it by a negative number. So we're going to multiply this by -1 instead of +1. And look at that. We have exactly what we wanted. So whatever value is coming out of our bounding box height is now getting turned into a negative. That negative is being added to our position y and we're getting the downward motion that we want from our other text objects. Now another function block that you can incorporate in this type of scene is something called an offset. So let's say, for instance, you wanted to have an additional gap between each one of these lines. So say, for instance, you were typing multiple lines of text in a single line. I want to have a slightly larger gap between each object so that we can differentiate, this is line 1 and this is line 2, and we don't just wind up with what effectively would look like one big paragraph. So we're going to use an offset function block, and we're going to drag that onto our Visual Logic Editor. We'll take the output of our multiply function block and send that to the input of our offset, and then take the output of the offset and send it to the input of our text to position Y. The offset you can adjust. So let's say, for instance, I wanted to have an additional 50 units between each line. I'll set this to -50. And now I have an additional 50 unit gap added to my bounding box height. And that's a constant. So that gap will stay constant as I insert more characters into this particular text object. There you have it. Pretty straightforward. What else can we do? Well, we obviously need to do this 3 more times. So I want to use basically the same piece of visual logic here. And to make that even easier, we can copy and paste function blocks. So I know I need to use the same multiply and the same offset function block. So I'll just make a selection around those 2 blocks. I'll copy them and paste them. Then we simply need to use 2 different objects at either end for our output and input to affect our next line of text. So we'll go into our scene object, we'll go to text2's bounding box height, and we'll drag that onto our Visual Logic Editor. We'll take the output into the input of our multiply, and then we'll take text3 and its position, Y, and we'll take the output of our offset and send that to the input. And now we have the exact same function for our second line. So you can see how this can come together quite quickly once you get on the right track. We'll copy this again, paste, and we'll take the bounding box height of text3 and send that to the input of our multiply function block and use that to affect the position, vertical position, of text4. And that's it. So now I can type multiple lines in each text object. My spacing will stay consistent. Every text object will move properly in relation to the other, and we're good to go. Now, how do we affect that background object like I had in the example scene? So if we look at scene 2, I had this cube in the background. So we'll do something similar here in our new scene. I'm going to use a quad for this, but the principle would apply for any object. Could be a cube, could be a quad, doesn't matter. So we'll create a quad, apply material to it, and we'll place that behind our text objects, like so. I'll increase the width of this quad so that it spans the length of my text objects. And I'm also going to make a modification here to normalize the height and the scale properties of this object, because I'm going to affect the scale. But in order to affect the scale accurately, I need to adjust the height of this quad, because I basically want an increment of 1 or an increase of 1 unit in my Y scale to also create an increase of 1 unit in the object's height. So we're going to change the height of this quad to 1. We're also going to position the pivot point at +1 so that when I increase the scale, my object scales vertically in a downward direction. Because obviously my text objects, as I insert line breaks, they're scaling in a descending fashion, and I want the quad to do the same thing. So we just want to make that one modification so that it scales from its top edge effectively. Now we can incorporate that into our Visual Logic as well. So we'll go back into the Visual Logic Editor, and we're going to go into our scene objects, and we're going to find our quad object, which is called quad 1, and we're going to be affecting its Y scale So we'll drag quad 1, scale Y. Now I need to take all of the heights, all of the bounding box heights, add them together, and use that to create my final Y scale. Because remember, the scale of this object should reflect the total height of each text object. So we're going to use a different modifier here as well, or a different function block. We're going to go into our math function blocks, and we're going to use an add function block. This is a really useful tool. We're going to take the output of each bounding box height, which can be sent to multiple function blocks, by the way. So we'll take the bounding box heights output, and we'll send that to the input of our add function block. And we're going to do the same thing for text 2. And we're just going to add that. We're going to take text 3, add that. Notice as I add more values, I get additional addition inputs. So we need one more. We also need text 4's bounding box height here as well. So we'll take text 4, bounding box height, and we'll take its height and send it to an input as well. And then we can use the output of that to affect the scale of our quad. And there it is. Now there's one thing we haven't done. I added an offset to each one of these text objects to handle the spacing. That offset has not been taken into account in the scale of our quad object. So if we look at our visual script, you'll see that each one of these text objects has a 50 unit offset applied to it. So I need to factor in those values into the scale of this quad. So we're going to add an offset here as well. So we'll go into math, we'll select offset. We're going to put the offset between the output of our add function block, and then we'll take the output of the offset and send it to our Y scale of the quad. Now we can adjust this offset however we see fit. And you'll see as I increase this value, we see the quad grow accordingly until we get it to a height that looks about right. So, 150 units roughly. And now that object scales exactly the way we want it to, regardless of the line that we're typing into, because we're adding that offset. Pretty straightforward. So that's the new visual logic feature. Obviously, this is one specific example. There's a lot more that you can achieve with this feature set. So we hope you look forward to experimenting with it, and please give us your feedback, because this is a feature that's going to grow with the product over time. So, as you use the visual logic features, please let us know if there's anything that you'd like to see added or anything you'd like to try, and we hope that it really turns into a powerful tool. Even more powerful tool than it already is. So thanks for watching, and until next time, see you guys later.